This is question 20, and it's a question involving surds, which is another way of saying roots. So things like square roots is surds. So we can see here what we've got is a sort of classic example. We've got surds on the top, so we've got the root 80 as a surd, we've got the root 5 as a surd, and we've also got a root 5 on the bottom as well, so that's a surd. And we're going to write it, we're changing the form, so it's going to look like this. And in fact, this is called rationalising the denominator. So what we're going to do is rationalise the denominator, which means get rid of any surds in the bottom of the fraction. So the denominator is the bottom of the fraction. So to do this, since the bottom of the fraction is 5 root 5 minus 5, we have to multiply the bottom, multiply in fact top and bottom of the fraction by, we rewrite this, so the 5 root 5, but what we have to do is change the sign from a minus to a plus. So if the sign had originally been a plus, we'd actually multiply top and bottom of the fraction by a minus. But because this is a minus here, we change this to a plus. So we just swap it over. The great thing about doing this approach is that it gets rid of the surd in the denominator. So we'll just do the bottom of the fraction first, just to demonstrate this. So what we've got is 5 root 5 minus 5, and I'm going to times it by 5 root 5, but this time change the sign to a plus. So what I've got to do, this is the same as multiplying out double brackets, so I've just got to be careful to make sure I have a system for doing this. So I'm going to do 5 root 5 times 5 root 5. So the 5's there, the actual 5's not under the root, make 25. And then I've got root 5 times root 5. I'm just going to write it like this for the moment. When you get more used to doing these, you'll sort of jump past these steps. But that's what 5 root 5 times 5 root 5 will give us. And then I'm going to do 5 root 5 times positive 5. So that gives me 5 times 5 is 25. And then that's root 5. Now I'm going to do the minus 5 times 5 root 5. So that's going to give us minus 25 root 5. And now I'm going to do minus 5 times positive 5. So that's going to give me, since I've got a minus times a plus, I've got minus 25 there. So I'm going to tidy all this up a little bit. Now, you might have noticed that I've got a plus 25 root 5 and a minus 25 root 5. And this is why this method works, because they cancel each other out. So they disappear. And then the other thing is, if you've got a root that you times by itself, so root 5 times root 5, that actually simplifies to make 5, or makes the number underneath the root. So that becomes 25 times 5. The roots cancel each other out. So these have disappeared, and we've still got the minus 25. So what I've got is 25 times 25 equals 125. Take away 25, and that will give me 100. So what we've done there, by timesing the bottom of the fraction by 5 root 5 plus 5, I actually end up with something that's not got any roots in it. Now, when I multiply a fraction, for it to still have the same value, I've got to do the same thing to the top of the fraction as well. So for that, I've got the root 180 minus 2 root 5. So I'm going to times that by exactly what I times the bottom of the fraction by. So that's going to be 5 root 5 plus 5. So if we multiply that together, so just doing every step again, so I've got root 180 times root 5. So that gives me 5, doing the non-surd part first of all, so just the number bit. And then I've got root 180 times root 5. Then I can do 180 times root 180 times 5. So that's going to give me plus 5 root 180. So when I do that and I don't put a symbol between the 5 and the root, it means times. Now I've got to do minus 2 root 5 times 5 root 5. So the minus 2 and the 5 make minus 10. And then what we end up with is root 5 times root 5. And because I've got a root 5 and the same root there, same root 5, they cancel and that just makes 5. That's the root 5 and the root 5. Finally, I've got the minus 2 root 5 times 5. So that will give me minus 10 root 5. Okay, so it's still looking pretty complicated there. So what I'm going to do is I'm going to try and simplify the root 180 there. So now root 180, this is another surd thing when we're trying to simplify a surd. So this is what we're going to do. We're going to simplify this surd here. Right, so what I'm going to do is I'm going to look for square numbers that are factors of the 180. So the first thing I could do is I could take out 9. So I could write that 180 as being 9 times 20. And in fact, that's going to give me, I can separate that there. So it becomes root 9 times root 20. And root 9 is just 3. So that's 3 root 20. And that will simplify a bit further because the root 20 could actually be written as, so this thing here could be written as 3 root 4 root 5 because the root 4 is actually or 4 times 5 will make 20. So root 4 is 2. So 3 times 2 is 6. So that becomes 6 root 5. So we've got that 180, root 180 is actually equal to 6 root 5. So what I'm going to do is I'm going to replace the root 180 here and here by this simplified version of it, and I'm going to rewrite it. So what I'll get is 5 times 6 root 5 times another root 5 for the first bit. For this bit, that's going to be plus 5 times again 6 root 5. The minus 10 times the 5 there is minus 50. And then minus 10 root 5, I'm just going to leave like that. And if we go back up to the top, we can see that what we want is we want it in terms of root 5 as well. So that's what we're aiming to do, simplify it. So it is a root 5 there. So if I do that, now the this bit here, we've got a root 5 times a root 5. So that's just going to make 5. So this bit becomes 5 times 6 times 5. And then I've got plus 5 times 6 there. That's just normal numbers. That's 30 root 5 minus 50 minus 10 root 5. So I'm just doing this very gradually. You might want to jump a few steps possibly, but I'm just demonstrating all the steps as I go along. So from this step, I'm just going to tidy this up. So I've got 5 times 6 is 30, and then times 5 will give me 150. I'm also then going to just collect up the bits without the surds. So I'm going to take away 50 from that. I'm going to bring that there. And then I've got the bits with the surds, so the root 5s. So I've got 30 root 5 minus 10 root 5. So if I tidy that up, 150 take away 50 is just 100. And then we've got 30 root 5 take away 10 root 5. So it's 30 root 5s to take away 10 root 5s would mean I've got 20 root 5s. So that just simplifies to being 20 root 5. So that is our top line of the fraction. And if we remember from before, the bottom of the fraction we worked out to be 100. So what I'm going to do is just put them back together. So I'm going to write 100 plus 20 root 5. We'll bring them together over what we've got for the bottom of the fraction, which is just 100. Now, if we look at the format in which we're supposed to give the answer, it's actually an integer there, but then separate to a fraction, which is root 5 divided by another integer being a whole number. So we can actually separate this fraction out at the center there where it's added. So that can become 100 over 100 plus 20 root 5 over 100. And now 100 over 100 is just 1. And I'm going to simplify 20 over 100. I can see that I could divide top and bottom by 20. That would become 1. That would become 5. So it would be 1 plus root 5 over 5. And that's it. That's our final answer. So I hope that's been helpful. And if it has, please consider giving our video a thumbs up and also subscribing to our channel for more videos. Thanks for watching.